Welcome to class today, pre-calculus students, on Friday, November 1st. We're finally into the month of November, so not too much longer before, hopefully, Christmas and Christmas break. Also, Thanksgiving break's not too far away, so hang in there and keep working hard. Last day of the week, you will have, well, let me just stop right there and just put the announcements up before I get ahead of myself. You will have a quiz this week, and I will email that to you Saturday morning, Saturday afternoon sometime. So men, look for that quiz, please. Integrity sheets. I know that I'm not winning a popularity contest, and to be honest, I love you all. You know that. I care about you. I've told you that, but I don't care. It's something that you need to start taking responsibility for, and I feel like I am hurting you by doing too much for you in this one small area. Again, if I want to be really tough, I could say every day email me when you're done with your video. If you don't do it on time every day, points are taken off. I don't do that. I respect the fact that your families homeschool you and you might get behind a couple days and get caught up over the weekend. I get that, and I am for that, and we homeschool our kids. But when it comes to that test Monday, which by the way is a week from this Monday, all of the videos must be watched before you get to my house on that Monday, and all of the homework must be done before you get to my house on Monday. Also, if you want 5 bonus points, the review sheet has to be done. Mr. Harrod, you're really being tough. Actually, I'm doing exactly what a normal teacher would do in a normal school, okay? So, when you come into my house on test, actually I'm being a little looser than a normal teacher because I'm not making you do it every day. I'm letting you get behind if you so choose to. So on test Monday, when you walk in the door, whatever videos and homework is done, that's what you'll get credit for. Whatever's not done, you won't get credit for. And if the review sheet's not done, then you will not get the 5 bonus points. Now, you might have questions on the review sheet, and that's fine. I'm not talking about that. I'm talking about someone who has not even done the review sheet, doesn't know where their questions are, and they're behind. So I'm going to announce this every single day up until Monday. Your final first quarter grades are slowly being finished. When you turn in your test number 5, I will then grade it and shoot off an email to your parents with your 9 weeks grade. So I've sent off 2 of those, and I have 2 more to go. So keep all that in mind. Now let's go ahead and jump right into the notes. Grab your pens, pencils, whatever you use, your notebooks, your books, calculators, and let's go ahead and get started. Let's first of all go over what will be on your quiz. So you might want to take some notes on this, okay? On your quiz, I'm going to give you trig equations. Now, if you want some examples, it'll be from the homework that we did the past 2 days, which, if you need a little reminder, that was page 588. We did 1 through 8, all of those, and the next day we did 9 through 43, the odds. So any of those types of problems are fair game, okay? Any of those types of problems are fair game. Now, tonight's homework, or today's homework, Friday's homework, is going to be page 608, and we're doing numbers 5 through 15 odd. So you only have 6 problems on your homework tonight. Now the video is going to be a little long, but you only have 6 problems, so it all comes out in the wash in the end, okay? But any of these problems here that I'm going to teach you today are fair game for your quiz. So I would not take your quiz over the weekend until you've done these homework problems and these, and watch the videos and make sure all of your questions are answered. I am only a phone call and an email away, okay? So I'm here to help you. That's what will be on your quiz. It'll be a relatively small quiz, as you can tell, so be thankful for that. And make sure you study and make sure you're ready for your quiz. Now, I'm going to give you a bunch of sentence notes here. You do not need to write these down. You do not need to write these down. Just listen. I will tell you when you need to write something down. We've been covering material lately that personally I'm not really a big fan of. I know that trig proofs and trig equations aren't easy. I get that. I really do, guys. I know that, but you know what? We've waded through it and we've got it done. One reason for this, by the way, is because there really aren't steps for you to follow. I cannot say step 1, step 2, step 3, step 4, and here's the answer. It's just a lot of trial and error. And I think that's one reason that makes students dislike a lot of the types of problems we've been doing here lately. But now we are going to get into some pretty cool stuff, some pretty cool fun stuff. Okay, you're going to like this. You really are. We're going to be doing some word problems I think you'll find pretty neat. And we're also going to be learning some different ways of solving triangles. Okay, so it's going to be some pretty cool stuff, not like what we just did. We are going to start off chapter 7 today by looking at something called the law of signs. So this is what we're going to study today, the law of signs. Now I would like you to write this down, please. Write down the law of signs, lesson 7.1, and then if you'd like to keep track of the date, which I encourage you to do, the date today is November 1st. November 1st, hold on one second. November 1st, 2013. Okay, so there's the date for today. Law of Signs, lesson 7.1. Let's go ahead and get started. Don't write this down, just listen. Remember, to solve a triangle means to find the measurement of all three sides and also find the measurement of all three angles. We've done that before. Remember, I've given you right triangles like this, and I gave you an angle here like 30 degrees and a side over here like 6, and I asked you to solve the rest of the triangle, the right triangles, and we did that. So we should know what solving a triangle means. It means to find all three sides and all three angles. In the past, we did this with right triangles. I just showed that to you. Today, we are going to start solving oblique triangles. Now, in case you don't know what an oblique triangle is, it is simply any triangle that is not a right triangle. So that's pretty easy, okay? In the broad sense of the definitions, either a triangle is, or in the broad sense of classification, either a triangle is a right triangle or it is an oblique triangle. Okay, so in the past we learned how to solve right triangles. Today we're going to start solving oblique triangles. Okay? We are going to accomplish this by using the law of sines and the law of cosines. Now, the law of cosines, we will look at that later, okay, in this chapter. Today, we are going to learn how to use the law of sines. Got it? Today, we are going to learn how to use the law of sines. Now, if you wrote any of this down, that's fine. I didn't really feel like you needed to. I just wanted to remind you of some of the stuff we had done in the past. Do write this down, please. Here is the law of sines. A over sine of A equals B over sine of B equals C over sine of C. Now notice how this, notice that these ratios or fractions are set up based on a triangle like this. And actually, I'm kind of laughing at myself. I got these sides switched around here, totally. Sorry about that. There we go. All right, there we go. Notice how angle A is across from side A and vice versa. Notice how side B is across from angle B and vice versa. And notice the same thing with capital C and little c. The lowercase letters refer to sides. The uppercase letters or the capital letters refer to angles. So what this law of sines is basically saying is this. Please watch carefully. In any triangle, you can take an angle like A and take the sine of it and put on top of that in a fraction the side across from it. So that would go up top. Notice it'll be the same thing for angle B. Here's angle B. I can take the sine of this angle, sine of B, as long as on top of that fraction I put the side that is across from B. And that goes up top, okay? And the same thing with angle C, obviously. Notice here's angle C. I can take the sine of angle C as long as I put on top of that the side that is across from angle C. In this case, it's C, and it goes up top. If you do that, you are allowed to set all of these fractions equal because they are truly equal. Now, if you would like a proof of that, if you would like to see how this can be true, and it's a very easy proof to see, by the way, if you're curious, and I would like to get into it, we just don't have time, but you will see a proof of this on page 600, so should you choose to pause the video and turn over there and look at it, they show you how they come up with the law of sines, okay? So this is the formula you need to know. A over sine of A, B over sine of B, C over sine of C, they're all equal based on a triangle like this, okay? All right, let's continue on. Let's go ahead and jump right in and solve this triangle using the law of sines, okay? Now, first of all, the problem states, in triangle EFG, that's a lowercase e, so that's a side. Side E is 4.56, angle E is 43 degrees. Now remember, capital letter E and side E have to be across from each other, okay? Angle G is 57 degrees. Solve the triangle. That means find the other missing parts. Now, please watch what I do. I always draw a triangle that looks like this. I would encourage you to do the same thing. Let me go ahead and pull up our law. Hold on one second, our law of sines, there it is, and we'll drag it down here out of the way. Okay, now, I would do this in your notes. I would go ahead and draw a triangle. I always draw a triangle that looks like that. I draw it the same every time. I don't care if it fits the scale of what the angle is or the measurement. None of that matters to me. I just always draw a standard looking triangle, and I know it's triangle EFG, so I'm going to go ahead and label everything EFG. Then this is E, so I go straight across. This is little e. This is angle F, so I go straight across. This is side F. This is capital G, so I go straight across and put a little g. That's easy. That is so easy. Now, let's fill in everything that we know. We know that side E right here is 4.56. We know that angle E is 43 degrees. We know that angle G is 57 degrees. Now, after I've labeled everything, let's kind of list off to the side what we need. We know we need angle F, so go ahead and write that down. We know we need to find side F, and we know that we need to find side G. Now, I'm a pretty big advocate of finding the easy stuff first. So we know that all three angles inside of a triangle always add up to 180. So finding angle F is really, really easy. So I'm going to do that quick. If you add these two together, you get 100. So this has to be 80 to give you 180 for all three angles. So that's pretty easy. Go ahead and write that down. Now, let's continue on with finding the rest of the sides. Now, we do not have a right triangle, so you're not allowed to use sine, cosine, and tangent in their normal stage. But we are allowed to use law of sines. Law of sines works on any triangle, right or oblique. It does not matter, okay? So with that in mind, here we go. Notice that I have a pair. I have an angle, and across from it, I have a known side. You always want to try to look for a pair, okay? They go together. I have a number here and a number here. That's really important if you're going to use law of sines. You always want to have a fraction or a ratio with both numbers intact. So notice how angle E and side E go together. And you're like, Mr. Earhart, there's no E down here in the formula. It doesn't matter. Look, it could be E angle E, F angle F, G angle G. That doesn't matter as long as it's a side across from an angle, then we're totally fine. So I have my side, 4.56, write that down, that's my letter E, over, and E goes over sine of 43. Now look at that and see if you have any questions, okay? It's always a side over its opposite angle, a side over its opposite angle, a side over its opposite angle, okay? So I have a known side, E, over its opposite angle, sine of 43, and you always take the sine of it, equals, now, I don't care if we find G or F first, I'm going to go ahead and find G. So because I'm looking for G, then I put a little g up top. That pretty much makes sense to me. And so down below then, I must take the sine of G. And of course, G is 57 degrees, capital G that is. Now, do you see what I did? I put little e over sine of big E, little g over sine of big G. As long as they're corresponding like that, law of sines works perfectly. Now, let's go ahead. Let me get rid of this. Let's go ahead and solve this equation. And it's really not too hard to do, to be honest with you. You know by now when two fractions are equal, you cross multiply. So sine of 43 times g would be g sine 43. That's pretty simple. And then 4.56 times the sine of 57 is 4.56 sine 57. And now we're solving for g, so we're going to divide both sides by the sine of 43. Now when you divide this side here by the sine of 43, you're left with g. And when you divide this side over here by the sine of 43, you're left with 4.56 sine 57 over the sine of 43. Now, students, I'm going to be honest with you. I'm going to tell you exactly how to type this into your calculator. If you will type into your calculator, type in 4.6, type that in, then hit sine, and when you hit sine, this pops up, sine parentheses, then type in 57, then close the parentheses, then hit divide, so this pops up, and then hit sine, and up pops a parentheses, type 43, close it, enter. If you'll hit enter, that's all you got to do. Your calculator does all of your work for you. Now make sure you're in degrees, and make sure you get out 5.61, okay? All right, there we go. So now I know G equals 5.61. So the only thing left for me to find is side F. I'm going to go ahead and start off. Now look guys, yes, you have a pair right here. You have a big G and a little g, and you could use that. I'm just going to stick to the same fraction I had right here. It's my little e and my big E. You don't have to. You could use another pair if you wanted to, but I'm going to go ahead and use this fraction right here. So I'm going to pull it over here. All right. So that's my little e over my sine of big E. And now I'm looking for f. So I'm going to put little f over sine of f. Well, the sine of f would be the sine of 80 because f is 80 degrees right there. Now let's go ahead and solve. Cross multiply. F times the sine of 43 is f sine 43. 4.56 times the sine of 80 is 4.56 sine of 80. And then divide both sides by sine of 43. So f equals 4.56 sine 80 all over sine of 43. Now again, if you'll type that whole thing into your calculator correctly, you will get out this right here, 6.58. And by the way, I have checked these with the book. These are examples out of the book, and these answers are right, okay? So that's how you use the law of sines. Let's quickly review. I like to find the easy stuff first. So if you know two angles, quickly find the third one. After you find the third one, you're looking for a pair, an angle and a side across from each other in which you know both of them. If that happens, that's going to be the first fraction you're going to use. And then you set up another fraction and you go ahead and solve for the missing part. Okay? It'll take some practice, but you can do this. Now, most of your practice is going to come in your homework. I do not like to be a long, boring teacher, although I'm sure I am, but I try not to be. So you're going to practice most of this in your homework tonight. Okay? Let me grab a drink of water here. And let's continue on. Now we're going to get into some interesting stuff. So please pay attention. 3 more examples and we're done. Please pay attention. I've got some important notes you need to write down. Let's go back a page. This was called, by the way, I'd like you to make note of this somewhere in your notes. Just watch what I'm going to put here. Watch carefully, please. Okay? Now, watch this. You're not writing anything down yet, but you will be in a second. E, F, G, E was 43 degrees, E right here was 4.56, and G was 57. Now please listen, we call this write this down, you do need to write this down. We call this problem an angle-side case. An angle-side case. There are different cases we're going to look at. This is called an angle side, and here's why. I have an angle, and then a side. that I started off at the beginning of the problem. These are the three things that I knew: an angle, and a side. Now don't get confused, students. Watch this, please. Watch what I'm about ready to do. If this 4.56 right here, well, I really don't want that to happen. If this 4.56 had been down here on this side, please listen to this, you would not have had angle, side. You would have had angle, side, angle. Because here's an angle, then here's a side in between the two angles, and here's an angle. So we call that angle, side, angle. Okay, so understand that. But the problem we're dealing with was angle, then an angle, then a side. Angle, side. So we called this an angle, side case because the beginning numbers that we knew formed an angle, side. Now, I do need you to write this in your notes, so write this down. Now let's talk about the side angle case. It's the trickiest one, and here's why. Are you ready? Whenever you're given a side angle case to start off the problem, sometimes these types of problems have no solution. Sometimes these problems have one solution, and sometimes these problems have two solutions. Okay? Let me say that again. Now we're going to look at some cases called side angle case. It's the trickiest one. Sometimes this type of a problem has no solution, sometimes it has one solution, and sometimes it has two solutions. The tricky situation that I'm referring to only happens when it is a side angle situation. Got it? That's the only time we have to worry about this tricky situation. So please make note of that. Let's look at a no solution side angle case. So write that down. This is going to be a no solution example, okay? So we have triangle QRS. So what have I taught you to do? First of all, you draw a standard triangle, nothing fancy, just like that, and we go ahead and put in QRS. And then next we fill in the blank. So here's side Q over here. Side Q is 15. Little r, side R is 28, and then angle Q is 43.6. Now, you need to learn to recognize these scenarios. Do you not see what we have? We have a side, then an angle. Or I guess you could say angle, side. Either way, it's the same thing. It doesn't matter. But we do normally call it the side angle case. So do you see why we call it side angle? You're given a side, then an angle. Now, if this angle right here had been right here, students, you do not have side angle. You have side, then an angle in between the two sides. So it's called side, angle, side. So this here would be an example of side, angle, side. Do you see the difference? The angle is between the two sides, okay? But if your angle is right here, that's side angle. Or if this angle was up here, 43.6, that would also be side angle. Same thing, okay? So you've got to learn to recognize this scenario, because when this scenario happens, you're either going to have no solution, one solution, or two solutions. So let's go ahead and try to solve this, okay? Now, first of all, let's write down what we're missing. We're missing angle R, and we're also missing angle S. Now, I wish we knew two angles, because remember, when you know two angles, it's really easy to find the third one, but we don't have that luxury. We're also looking for side little s, okay? Because we're missing that right here. Side little s right there, okay? Now, there's no quick angle we can find, so now we go ahead and do what I taught you to do. We look for a pair, and here's my pair right here. I know this angle, and I know the side across from it. So there's my pair I'm going to use for law of sines, all right? Now, don't forget, here's my law of sines right here. We'll run it over here. Remember, it's always a side over the sine of the opposite angle equals a side over the sine of its opposite angle equals side over the sine of opposite angle. So I'm going to take my side of Q, which is 15, I'm going to put that over the sine of Q, which is 43.6. Okay? If I can get my pen to work, 43.6 equals, now look, there's no way you're going to use S. That's two unknowns. You don't know this angle and you don't know this side. So there's no way we're going to use S. That would be two unknowns. We're going to have to use R. Now we know side R is 28, but we do not know angle R. So we're going to put sine of R. But we do know side R, which is 28. Okay, let's go ahead and cross multiply. 15 times sine R is 15 sine R. And then 28 times sine 43.6 would be 28 sine 43.6. And now we're trying to find R, so we're going to divide both sides by 15. So if we divide both sides by 15, we have sine of R equals 28 sine 43.6 divided by 15. Now, students, with your calculator, and I don't have mine in front of me, and I apologize, I have it worked out already. Well, anyways, if you'll go ahead and type this in, I'm not sure exactly what decimal you get out, and I apologize, okay? And I don't have a calculator handy. I think my son is using it, but it really doesn't matter. If you'll type into your calculator 28 sine 43.6, and then hit enter, and then divided by 15, and then hit enter, you'll get out a decimal. So now what you should have is sine of R equals some decimal number. Are you following me okay? And now what you can do, aren't you looking for an angle? Yes, you are. You're looking for angle R. And I've taught you in the past, when you're looking for an angle, you now hit second sine on your calculator, inverse sine, and then type in this decimal. Now if you do that, you should get out no solution or undefined or can't be done or whatever your calculator says. So right away, as soon as that happens, you know this triangle is impossible to have. In other words, you cannot have a triangle that has these dimensions. At all, Mr. Earhart? At all. It's impossible. And so the answer to solving this triangle is no triangle exists. Or if you just want to put no solution, I have no problem with that, but no triangle exists. So there's an example of a side-side angle case where there's no solution. Okay? Let's do two more examples. Now let's take a look at a one solution case, and I should have squeezed in the words, and I really want to do this. I need to. And this needs to be here, so put it in your notes if you're typing here. It should be side-side angle case. Very important. Okay, so now let's take a look at a one solution side-side angle case. So on a test or a quiz, I'm not going to tell you if it's a side-side angle. Okay, you're going to have to learn to recognize that. Okay, so on your quiz tomorrow, what you would do, you would not know is a side-side angle case. So what you would do is on a test is you would draw your triangle very quickly like that. And then you would see its triangle XYZ. So you put an X, then a Y, then a Z. Then for side X, we're going to put 23.5. For angle X, we're going to put 39.7. And for side Y, we're going to put 9.8. Now on a test or a quiz, as soon as you filled that in, you can see right away you have side angle. So on a test or a quiz, as soon as you see excuse me, that you have side angle, you know right away you might have no solution or one solution or two solutions. So let's go ahead and fill everything else in. Here's Z. So I know this is little z over here. So what I'm looking for is angle Y, angle Z, and side little z. That's what we're looking for. Okay, well, I have a question for you. Do we know two angles? We don't. We only know one. I wish we knew another one. We could find the third angle very quickly, but we can't do that. So now we look for a pair, and here's my pair right here. I have an X and an X. So I'm going to use that. There's my law of sines right here. I'm going to use that to open up my law of sines. So I'm going to go ahead and put 39.7 over, that's incorrect, sorry about that. I'm going to put 23.5, the side, the length of the side, over the sine of 39.7 equals, now we're definitely not going to look for z because I have no number here and no number here. That'd be two unknowns. So I'm going to use my y and my y. So my little y is 9.8 and my angle y is just that. It's y. That's what I'm looking for. So sine of y. Okay, let's cross multiply. 23.5 times the sine of y is 23.5. Sine y equals, and then we cross multiply 9.8 times the sine of 39.7. All right, now we're going to divide both sides by 23.5, obviously. So let's go ahead and see if we can't pull that over. So I'm going to bring my (23.5) over. So what I did there is I divided both sides by 23.5. Now again, I apologize. You know I try to be a prepared teacher. I do not have my calculator. But if you type into your calculator very carefully, 9.8, and then hit sine, and then up pops a parentheses, and you type 39.7, close the parentheses, hit enter, and then divided by 23.5, enter. You should get sine y of some sine y equals, then you should have some decimal number over here. I don't know what that is, okay? But if you've gotten this, actually should be a capital Y right here. So sine of y. Now, if you've gotten that far, you should realize I'm looking for an angle, and Mr. Earhart's taught me whenever I look for an angle, I hit second sine, and then I type that decimal number in. Now, if you do that correctly, let me look at my notes here. If you do that correctly, you will get out 15 degrees for y. So angle y, if you've done all of this correctly, will give you 15 degrees. So I'm going to come up here. I'm going to put 15 degrees. I'm going to come over here and put 15 degrees. Okay? Now, we have to stop right there. Now, here's where it's going to get really confusing. Please listen to me. Please listen to me. I can teach this well if you'll listen to me. Now, when we first started this problem, you should have realized right away we had what case? Side, side, angle. And students, anytime you have a side-side angle problem, let's go back a problem, and you get no solution, those are easy. I mean, as soon as it fails, you know you're done, no solution. But on one of these where you actually get out a number for this angle, then you have to do this, okay? And here's where it gets a little interesting, okay? Now what you're going to have to do next is you're going to have to check this angle, and sometimes y can be two different angles. Or in other words, let me say it like this. Whatever angle you just found, sometimes there can be two of those. Okay? I know that's confusing, but it happens sometimes. So, well, Mr. Earhart, fine. I'll trust you. Let's say you're right. How do you know? Well, here's how you know. Watch carefully. If I were to draw another triangle and have y up here like this, what I do is I take this angle right here. Now that's the angle I just solved for, correct? Right? You take the angle you just solved for, and are you ready? You always, Mr. Earhart, always subtract it from 180. Always. So you take 180 degrees and you subtract 15 from 180. This number here will never change. Now I'm going to try to get into y later if I have time at the end of the video. The first thing I want to do is teach you so you know what to do. Then I can try to teach you y a little later if I feel like I have time. Now, you always take the angle that you just found and you subtract from 180. Now if I do that, 180 minus 15 is 165 degrees. So I'm going to put that right here. Now don't forget this angle right here is 39.7. Well, hold it. Stop right there. You know this triangle here cannot exist, because what do all three angles always have to add up to in a triangle? 180. Well, look at these two. You're already up to, what, 204 degrees? So there's no way there can be another triangle with a different angle y. It's impossible. Okay, so you stop right there. You know that this triangle here does not exist, so we're not going to worry about the second triangle, and we're going to go ahead now and finish solving this triangle, and then we'll be finished. So I'm going to say this one more time. You find one of the missing angles. Once you find that missing angle, you always subtract it from what? 180. And then whatever you get out, you plug it into that same angle, and you kind of use common sense and see if that triangle could exist. Well, Mr. Earhart, what if that triangle did exist? Well, I'm glad you asked, and if you'll look right here, We'll get into that in the next problem, the last problem we're going to do. But for now, we don't have to worry about it. This triangle does not exist, so we're going to get rid of it because it just doesn't exist. There's no reason to have it. So let's go like this, and let's go like this. And this triangle is gone. So let's go ahead now and let's finish solving this triangle. Now notice I know 2 degrees here, 39.7 and 15 degrees. So if I add those two together, I would get 54.7. If I subtract that from 180, what would I get? I'll subtract it very quickly. Subtract from 180, and you would get 5.3. I believe you get 125.3. So we know that angle Z has to be 125.3. Now I am trying to save time here, students, okay? And so I'm not probably going to go, I'm going to go ahead and set up Z, but I don't think I'm going to take time and solve it because I think you know how to do that. But there is angle Z. Now I only have one piece left to solve, and that's side Z. Let's go ahead and use our original pair right here. So we have 23.5 over sine of 39.7 equals, and now we're looking for Z, and by the way I found Z, I should have wrote it right here, it's 125.3, so there's Z. So 23.5 over the sine of 39.7 equals side Z over the sine of 125.3. And I don't think I'm going to finish this, but I'm going to go ahead and take it a little further, and then I'm going to go ahead and stop. Let's go ahead and cross multiply. So sine of 39.7 times Z would be Z sine 39.7. And then if I cross multiply here, I would get 23.5 sine of 125.3. Next, I'm solving for Z, so I would divide both sides by sine of 39.7. So I would divide both sides by sine of 39.7. And so Z equals this right here. Now, if you were to type that into your calculator, and I'm looking very quickly as to what you would get, for Z, you would get 30.2. If you typed it in correctly, you will get 30.2. Okay, I'm not going to go ahead and get into typing that in, but you would get 30.2. One more problem and we're done, and then I want you to diligently work on your homework, okay? Diligently work on your homework. All right, now let's take a look, and by the way, once again, I need you to write side angle in your notes here. That's just very important to do. So we're going to call this a 2-solution side angle case. You need to have that in your notes, okay? All right, now on a test or a quiz, I will not tell you that you have side angle, okay? Let me grab a drink of water here. However, you should recognize it right away as soon as you do what you're supposed to do, which is to, of course, draw a triangle like this, and then we're going to fill the triangle in as triangle ABC, so ABC. It looks like B is 15, looks like C is 20, and angle B is 29 degrees. And notice what we have, side angle. So on a test or a quiz, as soon as you see side angle, as soon as you see that, you know right away that you could have no solution, one solution, or two solutions. Okay, makes sense? So I wish we could find one. Let's go ahead and list what we're missing. We're missing angle A. We're missing angle C, and we're missing side A. Now, I wish we could find one of these angles quickly, but we can't, okay? So we're going to have to go ahead and find a pair and use the law of sines. Now, here's my pair right here, angle B and side B. So I'm going to put 15, which is side B, over sine of B, which is sine of 29 degrees. Equals. Now there's no way I'm going to use A and little a because that's two unknown numbers and that's two unknowns, but I can use C and little c. So I have a side of 20 over sine of capital C. Now I'm going to go ahead and cross multiply. So 15 times sine C would be 15 sine C equals 20 times sine of 29 would be 20 sine 29 degrees. Now we're going to divide both sides by 15. So I'm left with sine C equals 20 sine 29 degrees over 15. Now, again, I apologize. I do not have this typed into your calculator, but if you typed in 20 sine of 29, enter, divided by 15, enter, you're going to get sine of C equals, and then you'll have some decimal number over here. Okay, I don't know what that decimal number would be. But next, you should realize by now you're looking for an angle, and I've taught you anytime you're looking for an angle, you use second sine or inverse sine. So type in inverse sine, then type in that decimal number, and if you do all of that correctly, let me find my notes here and look at it. If you type that in correctly, for angle C, you will get 40 degrees. I'm rounding that, of course, but you'll get 40 degrees. So angle C is 40 degrees. So I come over here and I put 40. Now, hold on a second, okay? Remember, this is a what case? This is a side-side angle case. So you always got to check and see if another triangle could possibly exist. So let's see very quickly if another triangle could exist. A, B, C. We know that this angle here is 29. We know this has a side of 20. This is 15. And now stop. What angle? Don't put a 40 over here. Remember, you just found 40, right? And what I teach you in the last problem, whatever angle you find, you always subtract that from 180. Always 180. I'll try to explain why later if we have time. So I just found angle C, which is 40 degrees. And so now I take that 40 and I subtract it from 180. So 180 minus 40 equals 140. So I come over here and I put 140. Hey, look at this. This triangle does exist. I have 140 plus 29, that's 169, right? 140 plus 29, 169. So that means this has to be 11 degrees. So this triangle is definitely possible. You know what the bad news is? The bad news is if two triangles exist, two possible triangles, you're going to love this. You got to solve for both of them, okay? So that's just how it is. So I'm going to solve this triangle a little bit later. So I'm going to grab it and drag it over here, and we'll finish solving that later. But at least you see now that I do have two triangles. And again, how do I know that? Well, what angle did I just solve for? This one. And you always take it and subtract from 180. So I did that, and I got 140. And then when I got 140, I wrote that in right here, 140, and I added 29 to it, and I wanted to see if it was possible to still put an angle here and get 180 degrees, and it was. So that other triangle is possible, okay? So we'll solve this other triangle here in just a second. Now let's come back over here. We found angle C. Now let's find angle A very quickly. 29 plus 40 is 69 degrees, so that would be 111 degrees. 111 degrees. So that's easy enough. And now we simply have to find side A right here. Well, I'm going to stick with my original pair, B and B. So I have 15 over sine of 29 degrees equals, and now we're trying to find length side A. So side A goes with the sine of capital A, sine of 111 degrees. All right. We're going to go ahead and cross multiply. A times the sine of 29 is A sine 29, and 15 times sine of 111 is 15 sine 111. Now we're solving for A, so we're going to divide both sides by the sine of 29, and if we do that correctly, we'll divide both sides by the sine of 29, so let's move that. That's an equal sign, by the way. Doesn't look like it. So A equals 15 sine of 111 degrees divided by sine of 29. So you would type 15 sine, pops your parentheses, 111 degrees, close your parentheses, then hit divide, and then type in sine of 29. enter. And if you do that correctly, for the length of A, you should come up with 29. 29. Now let's very quickly finish the last triangle and we're done. And actually, we know 3 angles, we know 2 sides. All we have to do is find side A. So we already have our pair right here, my B and my B. So I'm going to say 15 is my little b over the sine of my big B, sine of 29, equals my little side A over sine of capital A, which is 11 degrees. Let's go ahead and cross multiply. A sine of 29 equals 15 sine 11. And now divide both sides by the sine of 29. So A equals 15 sine 11 degrees over the sine of 29 degrees. Type all this in. Type in 15 sine 11 degrees. Enter, divided by sine of 29, enter. And for A, you should get out 6. Of course, I'm rounding that, but A equals 6. Now, students, I hope you've listened well. Here's your homework. I've only given you 6 of these to practice. I want to encourage you to practice, 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 practice. I said it 6 times for 6 problems. These need to be done. If you're confused, watch the video. Check your answers in the back of the book. Make sure you're getting them right, and make sure you're ready for your quiz over the weekend. Call or email if you have any questions at all. And I will email your quiz to you Saturday morning or Saturday afternoon. And it will not be a very long quiz, so finish that over the weekend. And the sooner you get that to me, the sooner I will grade that for you. Have a good weekend.